Hello, hello. So we're back with another session of low level design practice. I think we've done, how many have we done? We have done blackjack, coffee vending machine, elevator, library management, LRU, and Stack Overflow, right? 3, 4, 5, 6 problems we've done. So we're gonna do the 7th one today, and we're gonna mix it up, and I'll do it in Golang instead of Python. So let's see how it goes. First, let's find a question. Restaurant management system, what is that? It should allow customers to, what was PubSub? Should allow publishers to publish messages to specific topics. The subscriber should be able to subscribe to topics of interest and receive messages published to those topics. The system should support multiple publisher and subscribers. Messages should be delivered to all subscribers of topic in real time. The system should handle concurrent access, ensure thread safety, scalable, efficient in terms of delivery. Messages should be delivered to all subscribers of topic in real time, right? How are we going to ensure this? Is there something in Go channels that we can use? Usually, from my understanding, Go channels, if you take out, like if one of the Go routines takes out something from the channel, the other Go routine won't get it. In Go channels, can multiple Go routines listen onto the same channel and get the same data? I don't think this. Yeah, okay. So they can listen onto the same channel and receive the same data. On code feature channel makes it useful for. But you said it becomes available to any Go routine that is reading from that channel. The first Go routine that is ready to receive the value will get it. If multiple Go non-deterministic. Oh, so I did not know this. I thought that only one of them would get it, but interestingly, all of them get the value, right? So, like for example, in this function, they have created a channel, integer channel, and they have started a Go routine in which they there's a blocking call where 42 is put onto the channel, and then there's a Go routine which reads from the channel. There's another Go routine which reads from the channel, and that's pretty much it. And in this example, both Go routines will receive the value 42. That's pretty cool. So this pub subsystem, I think we can do this one. One interesting aspect of this would also be that we will get a chance to practice Go routines. So let's create a new folder, say pub sub. We'll see how to implement this, but let's requirements.txt, and let me just add this file here. Why is this highlighted? It's .txt file only, right? Rename to maybe question.txt. Yeah, maybe requirements.txt is a very specific file that VS Code has. Let me just check the volume. Hello? Yeah. Okay, so PubSub system should allow publishers to publish messages and to specific topics. So basically, PubSub sort of works like this, right? So we have a basically some sort of a system which has in itself multiple topics, I guess, and let's call this a pub subsystem. So it's sort of like a message queue, right? That we are allowing multiple topics, multiple publishers can put onto the topics, and then I guess multiple receivers can listen onto it. Yeah, so maybe like a Kafka or something like that. Kafka obviously is much more complicated than a simple thing because it supports persistence, it supports other stuff as well. But to subscribe to topics of interest and receive messages published to those topics. It says that it should be thread safe. Thread safe. I think if we're using channels, do we really have to use locks? Is what I'm thinking. Usually, like if I had to implement this without the use of Go channels, then definitely we would have had to use locks. But I feel like a lot of the functionality is already built into the Go channels, right? Because multiple subscribers can anyways read from the channel. Yeah, so let's try it using Go channels. I don't think we need to use a lock in that particular scenario, a mutex lock, because that feature is sort of already built into the Go channels, I guess. The other design decision which we need to think of is whether to use a buffer channel or not. The difference in Golang, basically the difference is that in a normal channel, the receiver and the sender would block till the other one is present. For example, the sender would block till the receiver is present, or the receiver would block till the sender is present. But if in a buffer channel, it starts blocking only after the buffer is full. So if, for example, there's a buffer of 5 elements and you have a sender which sends it onto that channel, but so till that 5 elements are not there in the channel, the sender won't actually block. But in this case, I think for the receiver it makes sense for the block, because the receiver in real time is just trying to pick up stuff from the channel. And for the sender, do we want to block for the senders is what the question is, right? I guess we can do any of them. Right, we can keep it as blocked or unblocked. I don't think it would make too much of a difference, to be honest. I think even in the code implementation, it would just be that when we are defining the channel, we just add a number while making it. Anyway, so there's a PubSub with multiple topics. I'm doing this exercise mostly to learn more about Golang and kind of practice Golang a little bit. So I think it makes sense to use the channels approach. Okay, so we have a PubSub system which can have multiple topics. If I look at the classes, which I'll probably have, let's call it classes, right? And we have a PubSub class, and a PubSub class would probably have a bunch of topics, right? It would also have a couple of behaviors, like maybe add topic, right? It could have probably have delete topic, but I think for now, I think let's not keep delete topic, I guess. Subscribe, right, to topic. And so how do we want to do this, right? We have a publisher and a subscriber. So one way to do this is something can call subscribe on the PubSub class to become a subscriber essentially, and yeah, I think let's keep this publish and subscribe functionality here, and then we'll just use these. Alright, so an add topic, so there's a certain number of topics, and you have a subscribe to topic, and basically when you do subscribe to topic, you should get a channel, right? You should, maybe as a return, you should get a channel. For publish, you should also sort of get a channel, right? And then you can just publish to the channel. or should it be just get channel or get because otherwise in publish maybe publish should take in a channel and content, right? Because when you publish, you're publishing to a particular channel, so we just call publish with the channel and content. But how will the caller client code get access to the channel? I guess we need a get channel function as well. Oh, okay, I have another idea. Instead of the channel over here, it's gonna take up a topic, right? So maybe list topics. And when the client code kind of wants to publish, it's gonna mention the topic it wants to publish on and the content. And when it wants to subscribe, it's just going to call subscribe on topic, and maybe it will receive a channel or something like that. Should it receive a channel? I'm wondering whether a channel should be exposed outside of the PubSub class itself. I mean, we do need some way to get the data. Anyways, let's do it like this and see. In terms of the variables PubSub would have, it kind of needs to have a map, I guess, from topic to channel, right? And the list of topics then we have. When we add topics, we basically just create another channel and another topic and add it to the map. Subscription, what it's supposed to do is it should return the channel corresponding to that particular topic, so that whatever the client code is or the receiver is basically the code which is calling subscribe. It should be able to, then it will just listen on to this channel. And then you have a publish, which gives the topic and content, and on that particular channel, basically inside the PubSub class, we're going to add that. All the data, we'll keep it as a string. We can maybe keep it as a string for now. We have a publisher. Do we need a publisher class? Publisher and subscriber class? Oh, that's interesting, right? Do we need a publisher or subscriber class? I guess we can keep it, because in this particular scenario, we need to create publishers which will keep adding to the topic, and then subscribers will keep listening. So from our main function, maybe we'll just spawn these publishers and subscribers. So let's keep a publisher and subscriber. When we start a publisher, we just start a publisher. I guess publisher is tied to a particular topic. We say that we want to start a publisher on this topic, and the data that the publisher puts in, that we can keep it as sort of hard coded, so we can run a for loop or something like that, and basically just probably mention the publisher name as well, right? We're gonna say, okay, this publisher on this topic puts this, and once you spawn the publisher, maybe your start function or something like that, which is going to keep working. For the subscriber, we create the subscriber and maybe another start function. Let's call the subscriber topic and name, and we're gonna handle everything in the start functions itself. Yeah, I think that makes sense. So in terms of how the project should happen, let's create a main.go file. These other PubSub, publisher and subscriber, maybe we can do it in different packages. We also kind of learn about Go packages and how they work, so I think that's a good idea. So we'll create a publisher folder. We'll create a subscriber folder. Oh, that's a spelling mistake over there. Subscriber folder. And let's do one thing. Let's sort of create a PubSub folder as well. So in Golang, I think it's a good convention to follow that the the folder names are like similar to the package names themselves. So that's why I'm kind of using these as this. So the subscriber would have a main function. The publisher and PubSub would basically just house the PubSub. Let's rename this actually, because it's the PubSub question. Okay, so now we have a question, we have a main.go file, we have a subscriber, PubSub and publisher. One thing I want to check real quick is in Golang, in a a new package. What should I name the file? Like if there's any convention. Go has a few conventions for naming files and packages. My lowercase letters and underscore to separate words. My package, but using hyphens. These are for package names. And file names is for my package.go. If you have multiple files and packages, they should have different names. Huh. Okay, we'll keep it simple then. So this publisher would have a publisher.go file. PubSub would have a pubsub.go file, and the subscriber would have a subscriber.go file, right? And then we have our main function where everything is gonna happen. Main, I guess we can import fmt for now. Fmt is the standard package for writing to the screen, and we have a func main. I think that's it. We're gonna see. So let's actually check if this program is at least working with a simple hello world. Let's say go programs. Let's go back. We get into the PubSub question. We can see our folders over here. Let's do go run main.go, and this should ideally print hello world. The first time running it, it's gonna take a little bit of time, I think, because it compiles the thing. So if I run it again, it should be much faster, I guess. Yeah, hello world. So at least our Go program is running at a very basic level. Then okay, let's try to create these classes. So Go doesn't have a concept of classes per se. So what we're going to do is we're going to Go uses structs to do that. So it uses structs, and then you can basically write receiver functions for those structs. So it kind of works like that. You'll see in a second what I mean. So let's get into PubSub. So here this is our pubsub.go. The first thing to do in a Go program is to give it a package, which we are gonna say is PubSub. Let us import fmt as usual. I think it makes sense to do that because we're gonna print out some statements. The next thing is, I think we want to create a struct. How did we create a struct, right? Do we do type and I guess the name, which is pubsub struct. I think it was like this. I'm not 100% sure. We'll see if there's some errors in this. Right, we create a pubsub struct, and what did we decide? It is going to have a map from topic to channel. How do maps work in Go? I think maps in Go. Oh, it's just a map. Okay, that's great. So what do we want to call the map? I think it's the topic channel map. Let's keep it simple. The type is a map from string to channel, I guess. I'm not sure if I think we do need to define the channel's data type. Creating a channel in Go. Let's see. Oh, it's Jan. Okay, I think it's Jan, and we are gonna keep present, right? I want to create a string channel. String, right? Actually, we can keep present, and we'll just number the messages and see how they come up. So I think it makes sense to do this as well. Just to verify, make a map from string to a channel. Yeah, that's the format. So we got our topic channel map, right? And there's a couple of functions over here. the first one is list topics. So func, and so in Golang you have to write receiver functions if I'm correct. Let's say object, and we have to decide whether we want to pass a pointer to pubsub over here, or we want to pass a the actual value. So if you want to modify something inside the topic channel map, it makes sense to basically, if you want the exact channel, then it makes sense to do that. Otherwise it's fine. So in this case, I think for the list topics function, I think it's okay just to pass a the value, but I think in our particular case, let's just pass the the pointer receiver functions with pointer. How do we do that? Yeah, that's how we do it, right? Object my method. Yeah, so I think the syntax is fine. And in this, basically what we want to do is we want to go through the topic channel map, and we kind of want to go through each key in the map and print that out effectively. So we say fmt.println the following topics are present, right? And Golang loop through keys of map. Oh, it's as simple as that. I thought, what if I want the value as well? I mean, it works like this, but what if keys and values? What's the difference? We just take two variables. Oh, that's pretty cool. Okay, that's easy. So let's call this topic, and let's call this obj.topic channel map, and now we basically get the topics. So we can print out the topics are present, and then these topics would basically get printed out. Do we need to do anything else in list topics? I don't think so, right? Awesome. So next we have a add topic object slash pub sub. Awesome. I mean, the difference between sending a reference to pubsub versus sending the object is only in one case it's gonna take the pointer value and make a copy of the pointer, and in the other case it's gonna make a copy of the entire struct. So in this case it's gonna take a pointer to a struct called pubsub, and then just make a copy of the pointer and send it over here. So in our topic we have to append it to the topic channel map, I guess. So new, let's say it's a new channel which we want to create, and that channel I think we have to use the make type, and I think that's the way to do it. So we make an integer channel which is called as new channel, and then we do object dot topic channel map dot I think we can just directly add this like this, and add topic would probably take a topic name. Is that how you do it in Golang? Golang named parameters. Let's see. Yeah, it looks like that's how you do it, right? So we got a topic name as a string, and Golang how to add to a map, how to check for existence of a key. Oh, that's how you check. Okay. So ideally in add topic, maybe we should check whether the topic already exists, and if it does, it's just gonna print it out maybe. So when we say a topic name, first we're gonna check if topic already exists. How are you gonna do that? We wanted the value, and okay, we're not gonna use the value, so that's why I have used this thing. And then we do object dot topic channel map for this topic name, and here if okay, one second, Golang check if not condition. Okay, it's sort of like C only. So if not of okay, then at this point, if okay, then we kind of know that fmt.println, we say that, you know, the topic is already present. I think that makes sense. And at this point, I think we can also sort of return from this function. Otherwise, we have to create it. So we create a new channel. It's not a buffer channel at, you know, for now. And then you do object channel channel map, and you give the topic name is equal to the new channel, right? So this should basically add a new topic. Awesome. So we have an add topic function. This, let's mark it as done. This, let's mark it as done. Then you have a subscribe and publish methods, right? Okay, let's start with subscribe method. This again is a receiver function, receiver pointer function, I guess. Subscribe method. Subscribe takes in a topic of type string. Let's call it topic name. Great. And what do we really want to do in a subscribe function? Subscribe and publish, right? So subscribe, so there are two ways to do this, right? One way is that you like return the channel, and if you return the channel, the calling go routine is gonna just listen onto the channel and keep listening onto the channel. The other way to go about it is probably to listen onto the channel right here, right? We can just say that, you know, right now in this code, it's going to listen onto the channel. If anything comes up in this topic, it's going to print it out. And then in the go routine, we're just going to have to call subscribe, and automatically that functionality will keep going. We won't have a way to cancel the subscription once it's started. I guess it's going to be hard to cancel it out. How exactly are we going to cancel the subscription? We'll need to find a way to cancel the subscription once it's called, I guess. Maybe we can keep it like a special keyword that in the channel, if quit is sent, or if, you know, some special number, maybe -1 is sent, at that time it cancels it out. Yeah, we can do that. Maybe we can do something like that, but for now let's keep the functionality over here only. So let's get the channel from the object dot topic channel map by passing it the topic name. We got the channel, and at this point what we want to do is we want to listen onto the channel indefinitely, right? Okay, so let's say we listen, receive from the channel. So once we got the channel, one second. So how do we receive from the channel? We do a channel and use this, and then we know it's let's call it received data, which is a variable of type int, and we say that, so this should help us get something from the channel. And once we have the received data, we can do and this would be a blocking call, by the way, right? We have a reference to the channel, and this will block till something sends something on this channel. So here we can say that, oh, 1 second, when we subscribe, we kind of also need to know the name of the subscriber, right? Maybe it makes sense to pass that as well, subscriber name, and we say that okay, subscriber name received, let's say received data should be actually I'm not sure whether we need to wrap it in, we need to convert it to a string or not, because println, because we're passing these as parameters, println should automatically do that, I guess. So this received data from channel, and then probably the channel name, right, or the topic name rather, topic name. And this operation of, you know, just listening onto the channel and printing it, we have to do sort of indefinitely, until we receive like a -1 or something on the channel. How are we going to receive a -1 on the channel though? No, so we'll control the subscribers. Okay, this will get out. So we have to do this till, so we have to keep listening on the channel. So here there has to be some sort of a loop which keeps listening on the channel, I guess. And if there's nothing on the channel, do we want to print out something like waiting for data or something like that? Maybe not. For beginning and out, let's not do that. We can keep a loop over here, right? Maybe that's one way to do it. We keep an infinite loop here, and in the loop we keep basically listening on to the received data and from the channel and printing it out. Is that okay? Golang function to read to indefinitely read from a channel and print the value. Does Gemini agree with our approach? Oh, we can read if the channel is closed. That's interesting. We should probably do that, right? So this, oh, okay, when we're receiving from the channel, we can do it in terms of value and okay, and if okay, this is definitely a better way to go about it, right? So it's similar to what we had done. Even this is using an infinite loop to get the same thing. Over here you can see that this is used because the value is being defined over here itself. We can define it at the top. That's also okay. We'll do okay, and we say boolean, and here we can technically do it like this then, right? And this is our channel. Awesome. And if not of okay, then a channel is closed and break. If otherwise, we just print out this thing, right? And it's obviously a value. Oh, that makes sense. Okay, so basically when we're listening onto the channel, we are also checking if the channel is closed or not, and only when the channel is closed is it going to say that okay, the channel is closed now. And it maybe makes sense to add this here, you know, just to say that this subscriber is kind of saying these things. It says received data from channel topic name, or it says channel is closed. So I think our subscribe function is kind of sort of done, and we can move on. So here let me just mark it as done real quick, and let's move on. Let's go to function object star pub sub, right, and publish function. Publish takes in a topic name, I guess, topic. So how is this gonna work? The publisher is, yeah, we'll just like put a stream of data inside, right? Maybe something like that. So it will take like a slice of integers, and maybe just put that onto the onto the thing. So it does have to take a topic name, right? String, and it will also take some sort of a data slice or something like that, and we define a slice of integer over here. Yeah, I think that makes sense. Okay, so now what does the publish method even do? It firstly it gets access to that particular channel, and then for each element in the data slice it kind of goes ahead and adds it to that particular channel, right? Loop through slice. Let's see. So we have a for loop which goes through it, or we can do it as this feels good, right? So we do for, we don't need the index and we need the value for sure, right? Range of data slice, I guess, and we have access to the channel and we just put in the value. That's pretty much it, right? Yeah, that's great. And at this point maybe it makes sense to also fmt.println. You know, we don't have a publisher name, unfortunately, right? We did have a subscriber name. Maybe we should keep a publisher name as well. So let's just say name, or rather publisher name, kind of, it's okay. And then we say that this publisher name says that adding probably value to channel, or rather to topic, and we give the topic name as well. So when we do this, we're going to pass in a data slice, and basically it's going to initiate a publisher. The publisher would call this publish function, and effectively it should work. It'll pass in a data slice and it would just keep adding to that particular channel. And we have only one instance of this map from string to int channel, which everyone is basically going to use. So I guess we are done with this as well. Now we need to write the code for our publisher and subscriber. So let's go to publisher first, and let's say this is package publishers. Okay, great. Let's import out fmt for sure. I think we need to import this as well, right? This time we need to import pubsub, I guess, because it's going to, I guess it's going to call publish or something like that. Yeah, I think it makes sense. So the publisher type publisher struct would probably have a name. Yeah, so this would have a name string, and it would have some data slice. Let's call it data slice of, it's integer slice. So I think a publisher, when we initialize a publisher in our main function, it makes sense to do something like this. We'll give it a name, we'll give it a data slice, and we'll also give it a topic, right? So we'll initialize the publisher like this, and inside the publisher, okay, we'll define a let's say object star publisher. Let's just define a start function, right? So now one important thing to note over here is, I think in Golang it kind of depends whether these things are in capital or not, whether they are available outside the package. So for example, this P should be capital if we want access to it outside. This P should be capital basically outside the pubsub package. So the pubsub package we're going to use in our publisher, subscriber, and main. I think these should be capitalized to make them visible outside. So let's make it so. list topics. Actually, come to think of it, do we really need to this to be capital? Like the pub sub structure itself, we can make do without having a capital, is it? How is this gonna work? How is that gonna call the, I mean, the publish, the subscribe, all of these are being called on that particular an object of that type, I guess. So we'll have to initialize a publish method and call that with a. Actually, even without the subscriber and publisher, this is gonna work, I feel, right? Because we're just gonna call publish and we're gonna, yeah. I don't think we even need a subscriber and publisher, because the pub sub already has a publish function and a subscribe function. All we have to do is create a small function for a publisher and subscriber. We don't need an entire class. I don't think there's not much over here. We can just create a function out of this. So let's do that. Actually, let's remove the publisher. Where's the delete? Yeah, so let's remove publisher and let's remove subscriber. Okay, so we have our pub sub, and in our pub sub, yeah, this is probably going to be a capital. And on our main.go, let's import this. So let's say, I mean, there has to be a better way to import, right, than writing import 2 times. Golang import multiple. Yeah, there definitely is. So okay, pub sub. Awesome. So we got our 2 imports. And what do we want to do here? Yeah, we'll probably create a function for publisher and subscriber, right? Subscriber. The publisher, when we are starting a publisher, what it's going to take? It's going to take a name. It's going to take a, let's say, ID, or maybe let's just call it publisher name. It's going to take a topic name, I guess, and it's going to take a data slice. Well, let's just call it slice for now, and it's going to be a slice of string objects, maybe, or maybe integer objects is fine. And a subscriber, it's also going to take in a name. It's going to take a topic name. I think that's about it, right? Is there anything else a subscriber needs to do? Not really, right? So it's going to call subscribe on an object of pub sub, right? Because pub sub object would have a subscribe function essentially, and the pub sub subscribe function, what it would do is would take a topic name and a subscriber name, and it would just work. So we don't even need this actually, because we already have it. And for publisher also we kind of have this, so maybe we'll just start off these publishers and subscribers over here. So let's first initialize the pub sub system, right? Let's call it pub sub. Let's start pub sub dot. Yeah, like I think it's sort of like this. And in this, when we are starting it out, we need to set this topic channel map to something. So we'll say this topic channel map, let's just make it, and it has to be a map of string. Basically it's a map of string to int. It's basically an empty map of string to int, and then maybe we add a couple of topics to it, right? So we have a add topic function, right? So we do pub/sub dot add topic, and let's give it a couple of topics, right? We say this is topic 1. Let's add 4 topics, 2, 3, 4. Right, so ideally we should have 4 topics right now. Just to test it out, we're gonna do pub/sub dot list topics, and for now let's remove this. Let's try running this, and let's see what issues come up. So go run main.go. Okay, there's some issue. Fourth, it's saying that it's expected that there's no comma in this. Okay, I did not know that. Alright, package pub/sub is not in Go source pub/sub. I'm a little confused. Why is it looking at in Go source pub/sub? It should look for it in the. Do I have to do it like this? Let's check it out. Golang, create a package and import it. I think there's some small issue where I'm not able to create a file in main.go inside our learn package directory with the following components, which is fine. And the line of code package main specifies that the file belongs to the main package. So we import the fmt package, compile the above program, moving to learn package. So this works. Importing simple interest package, and to use the custom package we must import it first. The import path is the name of the Go module concatenated by the directory where the package resides in the package name. Is learn package, I guess. We don't have a module, right? We just have a Okay, we structure the code in a way that all functionality related to a simple interest package. To do that, we need to create a custom package separator. It will contain the function to calculate simple interest. Before creating custom package, we need to understand Go modules first. First, Go modules are needed to create custom packages. Oh, nothing but a collection of Go packages. Modules create custom package. The answer is import path for the custom package derived from the Go module. So 1 second. Can I have a custom Go package without using a module? Yes, you can have a custom Go package without using a module. Module recommend. Here's a basic. Create a new directory. Choose the directory where you want to store the package. Create a Go file. Set the directory same name as the package you want to create. For example, if you want to create a package called my package, create a file. Define the package, which I did. Define function variable. Use the package. So it should have worked, right? This error I didn't understand though. Relative some programming. Oh, it got changed from 1.11. The Go path environmental variable specifies the location of your workspace. It is likely that the only set during. Oh, I probably need to set this, right? This is not working. Do I set go for this? Interesting. So let's try this out as well, I guess. And over here, what kind of a terminal? It's PowerShell, right? So let's look at what is there in GoPath, I guess. GoPath. So nothing is there in GoPath. Print working directory. Maybe because it's Windows, we'll do it like this. Okay, so we set the go path. Oh, we didn't set the go path. What happened? Why didn't it get set? Windows print env variable. Okay, so it's echo and then you wrap it in this thing. Okay. Yeah, that's weird. Still doesn't work, right? Set go paths Windows. Maybe it's better to just do modules instead. I'm not sure why. How do I use Go modules to create my custom packages and import them? Go modules provide a modern and efficient way to manage dependencies in Go projects. They allow you to create custom packages, easily import them. So you do in your project directory, run the following command to initialize a Go module. Go mod init. Huh. So this I've done. We've created a custom package, and this I've done. Defining the package also we've done. Define functions, another. Oh, that's it. Oh, we don't really have to do much then. Oh, we just didn't initialize it, that's all. So it's saying that over here we do go mod a init. Sorry. They did create a GoMod file. Okay, let's. I think we are. Oh, it worked. Okay, fine. That's great. So it created a GoMod file, and then we did a GoMod tidy. I'm not sure if it's worked or not. Let's try to run main. What's going on? Should have worked, right? Should have added a require directive automatically, I feel, because in the main we are using PubSub. I think go mod tidy should have automatically added something to the go mod file. I'm not 100% sure why it didn't do that though. Go mod tidy doesn't do anything. It's not able to find the package PubSub basically. So basically it's just looking at it in Go source, and since PubSub is not there in Go source, it's failing. So the C program files Go source, it's looking at it over there. Let's look at the environmental variable ones. Why is it looking at in the Go source, man? Let's do one thing. Let's maybe add Go path and add this into the Go path. So it's added, right? Go path is there. Right. Still checks in Go source. 1 second. Hmm. think it's because this instance of VS Code. Let me just restart VS Code. One potential issue is that maybe it's counting that as an old terminal, so it doesn't reflect the environmental variables. That's like one possible thing that could be happening. So let's at least verify that. Go run main. Ignoring go mod and go path. Why is it ignoring the go mod and go path? That's so weird. Huh? Go mod tidy gives an error saying that go mod is not found in the current directory. How is that possible? I can see the go mod file over here, right? And when I run it, it says it ignores the go mod and the go path. What's going on, man? Why is it looking in source? That's so weird. It says it follows that from the go path, but the go path I've set to pub/sub question, right? Why is it looking in? Or do I have to put it in a source folder? Is that it? Like, is it just gonna work now? Yeah, it's at least able to understand where it is. It's saying that there's a problem on line 6. I guess this comma is not there. Undefined pub/sub and source pub/sub.go, which is true, I guess. Undefined boolean line 21. It's what's the boolean in Golang? I have to read up on structure of a Golang problem though. I think for now it's fine. We set the go path and it looks for a source folder inside the go path and checks for basically our packages over there. So now the problem is in main.go, where it's saying that on line number 11 there's a syntax error, unexpected new line in composite literal, possibly missing a comma in this. Yeah, I guess. FMT imported and not used. Did I not use FMT? Oh, it's used on other packages, which is fine. Cannot refer to unexported field topic channel map in struct literal. Oh, even while initializing I can't. That's interesting. I did not know that. And and you probably have to change all of these. In fact, let's just say that if it starts with this, let's change it. Cannot use make this value of type map string as map in the where's the problem? One second, go mod id. I just want to run. Oh, Go modules itself are disabled when you do. Oh, okay. So Go module is equal to off just disables modules, and it just now it's kind of looking at Go path. Okay, and Go path expects a source folder to be there. Interesting. The 10th. So when I create this, this fails. Because why does this fail? Because this is of type. Oh, this is a chan. Oh, this is not a slice. Chan. Nice. The following topics are present. We are able to effectively add topics. As you can see that the topics didn't get printed in any order because it's a map and it doesn't preserve the ordering in which we are adding it. It's just a hash map. But at least it's working now. So now I think we can move on to the next part of it, which is creating. So let's try to create one publisher and one subscriber, I think. So let's say pub sub dot publish, I guess. Publish. So it needs a publisher name, topic name, and data slice, right? Yeah. So publisher name is first publisher. Topic name, let's give it as topic 1, and we need to define some data slice if I'm correct. So integer and just pass in 1 2 3 4 5. Okay, so we pass in this data slice, and basically what publisher would do is it would get that channel and then it would keep adding to that channel, which is awesome. So we are going to do it in a Go routine, and then we do pub sub dot subscribe, and subscribe takes in topic name and a subscriber name, right? So let's give it a topic name and our subscriber name. Let's call it first subscriber. So this we are not doing it in a Go routine because anyways we launched this publish in a Go routine. Subscriber would just come over here and keep reading from that channel. Doesn't make sense to do both of them in a Go routine. At some point probably this will end, right? This publish. So after adding, like publish after adding everything, should I close the channel? So if I don't close the channel, let's see what happens. I think it would just keep waiting. Okay, let's see what happened, right? So it says that it listed out the topics, then first publisher adding 1 to topic 1, first publisher adding 2 to topic 1, then the receiver starts receiving it at some point, first publisher adding 3 4 whatever, and it was till 5. Yeah, so the receiver subscriber, yeah, receive from 5 from channel topic 1. All Go routines are such slave deadlock. Yeah, correct. Because now what basically happened is in this particular sub publish function, it's added everything, and the Go routine, did it terminate? Or I thought this would just come out, right? I mean, this would keep waiting, I guess, but there won't be any Go routine which is putting it on this channel, so I guess that's a deadlock. Do Go routines automatically end? do I need to put an explicit return statement for it to end? Yeah, so function completion, this coroutine basically ends. So let's try one thing. Let's try to close the channel. How to close a Go channel. Let's see what happens. So the publishes stuff, and then it also calls close on the channel, I guess. But this, so okay, this isn't a deadlock, right? Because the channel got closed, and in the subscribe function what it did is it understood that the channel is closed and it closed it. But the problem is we don't want to do this. I get it. So this is working, right? So this is definitely working. Now let's try something. We are going to start a couple of subscribers. We're gonna do multiple subscribers now, right? All on the first topic. Let's do second subscriber and third subscriber, and let's wait for some time, right? And then we create this publisher, which is not in a Go routine. Great. Golang how to wait. अरे यार, Golang sleep for some time. Time dot sleep. Okay, so we need to import time and do time dot sleep and time dot seconds. Okay. So let's import time and do time dot sleep, and let's do a sleep for maybe 5 seconds. 5 into time. Actually, let's do it for 3 seconds. Dot seconds. That's it, right? Great. So ideally now all of them should receive it, right? So let's run it, and it will sleep for 3 seconds. And first publisher adding, second subscriber. Wait, what just happened? So we started 3 subscribers on topic 1, and the 3 subscribers are probably waiting on the channel, and then after this we put in 1 to 5 on the channel. The first subscriber, so publisher added 1 2 3 4 5, and the yeah, they didn't receive it, right? That's odd. That's really weird. Interesting. Why did they not receive all the data? So when we added the topics, we created a new channel, right? Yeah, I created a new channel. But when I remove these, it automatically starts working, is it? Oh, I think I understood what's going on. So correct, we have our publisher and we have our subscribers, but maybe our like main function exits, right? What happens if we spawn a couple of go routines and our main function exits? Oh, that's the thing. Okay, so how to wait for go routines to end? Yeah, got it. We have to wait out. Basically, our main function is ending, and because of that, the go routine get terminated. That's why nothing gets printed, and even before it was not taking up all the values in the topic because the main function was just ending. So this one is, it's saying we can use wait groups. Let's try that out. So let's create a wait group. Then you say that you add to a wait group and then you pass in the reference to that. How to wait for go routines to end. By incrementing the wait group counter with add, each coroutine signals that it needs to be waited upon. When a coroutine finishes its work, it calls done, reducing the wait group counter. Okay, so for example, why would it add 1 and 2 and 3 and 4, right? It should just add 5 and get it over with. Like, oh, it's not I, it's 1. Oh, okay, my bad. So here, suppose we are doing 4 go routines, and if we end up doing 4 over here, right? Actually, like a trick over here is also that we just add 1 and we do wg.wait, and since we didn't really pass the wait group anywhere, none of the go routines can actually call done effectively, and so this will just wait forever, right? Because we're not really, yeah, I think second subscriber received 5. So what happened? Runtime semi-acquire. So the publisher added. Why didn't the publisher added? All go routines are asleep. Received 5 from channel. So 1, 2, 3, 4, 5. So it didn't happen, right? Not all the. Unfortunately, all of them did not receive it. Probably because they're not waiting at the same time. Now let's also try the time approach. Right after we launch a go routine, let's say time.sleep. Like one possible case. So what's going on is it's gonna put in 5 things, and all of these 3 are not getting those 5 values. Right? Different go routines are getting those values effectively. You can see that 1, 2, 3, 4, 5 are put in by the publisher, and 1, 2, 3, 4, 5 are received, but they're received by different subscribers based on who is listening on to the topic at that time. So let's wait over here. 3 into time dot second, and then run it again, I guess. Let's see whether this works out. And then we got our, still didn't work, right? 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. They don't receive it. Why did I think they did receive it? Go routines. Do all go routines listening on a channel receive the value. Multiple coroutines listening on one channel. I have multiple coroutines trying to receive on the same channel simultaneously. It seems like the last coroutine starts receiving on the channel, gets the value here somewhere. The above output is outdated and more. This behavior, see comments. This behavior is not defined by the language specific scheduler, which is an implementation detail, will take care of it. Note that the work to be done is trivial and or one of the coroutine are fully started. All work might be scheduled to the first available coroutine. Nothing imposes to split the work equally. Prefer using formal arguments, avoid reading and writing on the same channel. Interleave the messages automatically. Okay. Receivers always block until there is data to receive. That means that you cannot have more than one coroutine listening to one channel, except all coroutines to and expect all coroutines to receive the same value. That's interesting. So yeah, effectively what's happening is coroutines are running on basically they Go has its own abstraction above the operating system thread, which is that coroutine runtime or some environment which handles swapping out of coroutines onto basically the mapping of coroutines onto OS threads is handled by some implementation detail in Go. And what's basically going on is that these coroutines which I'm spawning and they're listening onto the channel, they cannot listen onto the channel at the same time effectively, right? So if there are 4 coroutines listening onto the channel at the same time, internally the statement where they wait for something, for example the blocking call, where like in subscribe the blocking call where they're expecting something from the channel, effectively if we have 3 coroutines, for all 3 coroutines it's going to check this at it can't check it in parallel because it's not running on the same OS threads. Like it's not running on different cores or different OS threads, so it's checking them in a synchronous manner. So I think randomly one of them would get selected. So for example, in this particular scenario, our second subscriber actually got 3 and 5, third subscriber got 2, right? So second subscriber got 3 and 5 and third subscriber got 2. Will it change this time? 3 and 5 and third, so no, it didn't change, right? According to me it should be random. I mean, it shouldn't not necessarily be random. Yeah. So is it different seconds? Like the thing is, it's not necessarily random, but it's not guaranteed to be the same every time effectively. It can be the same in like 3-4 times I executed, it's possible it's the same, but I don't think there is any guarantee that it would be the same. But that's interesting. So effectively we cannot use Go channels to implement this PubSub because multiple channels cannot listen onto the same thing. So ideally we had to create a pubsub.go, and here instead of using channels as a way to house the data, we should have used some sort of slices and then check if all the subscribers have received the data on which has been put on the slice before removing it. Yeah, I think that's how it was supposed to be done. But it's okay. I think we learned something new about Go, and hopefully you guys also learned something if anyone is watching this. um, yeah, have a good day.